So we already have a video talking all about the sampling distribution and giving several different examples of problems that you can do with a sampling distribution. But I realized that there is a particular problem set in Knewton that students are really struggling with. So I wanted to take one of those problems straight from Knewton and work through it all in one go using the calculator functions, where we're using normal CDF and inverse norm in our draw me a picture method. So if you happen to have your formula card and calculator out, I really hope you do, but also if you happen to have your printable draw me a picture slides so that you can write on top of them, then that will be beneficial as well for the Knewton homework and for even this video. So recall that the formula card for chapter 7 looks like this, and we'll be using particularly this, but this idea as well. We won't use the z-score in this one. We will compute the z-score, but we'll do it using inverse norm, actually. And we won't be using normal CDF. But anytime that you see the tables, just think to yourself, nah, not going to use those tables, because everything you have in the tables you can get with normal CDF or inverse norm. Don't forget in chapter 7 to always divide by the square root of n on your last input on both of those. That's really the only thing that changes from chapter 6 to chapter 7, is that the very last input you divide by the square root of n. So here we are with our problem. We are looking at the top 7%. So we've got a video game company sells an average of 132 games a month at the store with a standard deviation of 9 games. The company is looking to reward stores that are selling in the top 7%. So we're going to shade the top 7%, just a little smidge at the top of the curve, at the far right of the curve is what we're going to shade. And then how many video games must a store sell in order to be eligible for a reward in the company? Well, that's that line that marks the bottom 93% and the top 7%. So the line that separates those two is where we're going to mark our reward. If the company is only looking at 36 of their stores. So 36 is our sample size. When we divide by the square root of n, that's going to be our 36. And of course 132 is going to be our mu, and then our area to the left is going to be, the left, this is the right, and so it's going to be the complement of this 7%, or 93% in other words. And we want to find the z-score, the sigma x bar, which will be easy, and x bar. And I think I'm going with finding x bar first. I think I did that. Yeah, so remember the x bar distribution. We've already talked about it a good bit. So this is the x bar distribution. Your mean of your x bars is still the same mean, but the standard deviation of the x bar distribution now divides by the square root of n. So we'll just label everything like we normally would. And the top 7% is here, and we have our mean of 132. And since this is the distribution of x bars, these are all x bars, even 132 is the mean of all x bars. And so we want to find the x bar right here that's going to give us the top 7%. And so that's inverse norm because it's below the belt, this being the belt right here. And so we have inverse norm, area to the left, so that's going to be 1 minus our 7%, or 1 minus 0.07. You could type in 0.93 here as well. It is just up to you. I wanted you to recognize where the 0.93 was coming from. It's because this is 7% and this has to be 93%. And then the mean is 132, and our standard deviation, we were told on the problem was 9, and of course we have to divide that by the square root of 36. And when we do all of that and we round, it asks us to round the x bar number to the nearest whole number, then we'll get 134. And on this one, we're going back and looking at the z-score. So the z-score is the distribution that always has a mean of what and a standard deviation of what. Okay, hopefully you said 0 and 1, because that's the big thing on the z-score, is that we do exactly the same thing we just did for x bar, but we make the mean always be 0 and the standard deviation always be 1. So let's look at that picture. This is what the picture looks like. I erased mu and put 0, and I erased sigma divided by square root of n and put 1 on both of these. So no matter whether you were finding probability or percentage, or whether you were finding the actual z-scores on the bottom, because this is the z-score distribution, you're going to replace the mean and the standard deviation with 0 and 1. And it's that simple. That's all you have to do, and you can compute the z-score. So on these, I kind of do second enter a lot and just change the mean and the standard deviation to be 0 and 1. Because it's going to be the same information, the same picture, the same area to the left, but now we just have 0 and 1. And so when we do that, you can see my previous and then this answer, 0 and 1. I happen to have a calculator that does left, right, or center. I could have put, if you happen to have one like this, you could have put 0.07 in right, because this is the right tail. So it won't, this one will take in the area to the left, or the area to the right, or the area to the center. You can just change this. But most of you don't have that option. And so just 1 minus 0.07, 0 and 1 is what you would use in that case. And so I just kind of always leave it the same and do left. So on this one, when it asks for 2 places past the decimal on this one, our answer would be 1.48, because anytime the next decimal is, or the next digit is 5 or more, we round up. So this would be 1.48 on this answer. And then the last question asks for sigma x. And so sigma x is, remember, sigma x bar is the sigma divided by the square root of n. And so our sigma divided by square root of n, we were supposed to give 2 places past the decimal on this one, but this just really has 1 place past the decimal with no rounding. So we'll just give this exact answer. When there isn't enough digits to give, just give whatever you have. But we haven't rounded this at all, so it's just 1.5. So this is what it would look like when we put our answers in. We would have a z-score of 1.48. We would have a sigma x bar of 1.5, and our x bar was 134, because it asked us to round that to the nearest whole number. And so those are how we get our answers, all using the calculator and the calculator functions, except for this one, because it's such a simple calculation, we don't really need a calculator function for it. And hopefully you can do every single one of these this way, where your z-scores, you're using 0 and 1. For your x bars, you are doing the regular mean, but sigma divided by square root of n on the inverse norm function. So hopefully that will help you be much more efficient in working through these Knewton problems. Good luck. Oh, and I should remind you that your formula card, your calculator, your lecture notes, including these, and then textbook and Knewton instruction and message me are your best tools.